let's do it. Enjoy. Hello everyone, September 25th. Alright, let's do this. What do we have? Valid triangle number. Yesterday was triangle, today's triangle again. Somebody's liking triangles. Given an array, nums, return the number of triplets chosen from that I can make triangles if we take them as sides. Oh! This is the question that I had in a Google interview. This is the question that I had in a Google interview. And it's a very good question. Okay, I think it's sorted, and then there's some trick. There's some trick to go with it. So yeah, you sorted this way, right? And then what we want is the two smaller sides. The sum needs to be bigger than the largest side. So what you do, there's one way is, you secure first two and you binary search. So you get the sum, you binary search, you find that. So that will go with O n squared log n, which is exactly what this one is. Because you have 1000, so O n squared log n, this one definitely works. We can do this pretty fast, but I think during the interview, I used this, and then I was asked, is there a better way? And I said, I don't think so. But the fact that you asked means there is a better way. I'm trying now to think what was the better way of doing this. I don't remember what was the better way. There is a better way. There is a better way. The triangle number. I think it's still sorted, but then oh man. It's like we set some number, and then like all the way to the right is all good, and then we just move into the left. You think? So, if the smallest and the second biggest, if these two is smaller than this one, right? Then there's no hope. So I can just move forward because this is already the second biggest one. Adding this, you add the other one. Actually, that's not true. That's not true. You add 2, right? If it's bigger than this, I can put pointer here. And then you move this one forward. Right? You move this one forward. And you add these two. If it's still bigger than this, then everybody inside can do. Until you hit a point where the sum is smaller than this. Then you move this. Right, you move this until because this plus this is smaller than this. So until you hit something that this and this is bigger than this, right? Then you'll find everything in between. Yeah, you find everything in between, and then you move. You try and move. So this one, yeah, this can go O(n) squared. Let's try. I believe we can do O(n) squared on this. Yeah, my cat is do a dry what should I call this? Litter. It's trying to do the litter on the floor. Yeah, interesting. All right. Anyway, so the quick solution, the naive solution, is to sort nums, then find, then go through all pairs, right? Go through all pairs, binary search to find the third value that is smaller than the sum of the first pair. This can solve the problem in O(n) squared log n. However, there is a better way, which costs only O(n) squared. We still sort, right? We still sort nums. Then we use 3 pointers. The first 2 points to, okay, we start with, call it A, B, and C. Now let's call it I, J, and K. The starting point is I equal to 0, J equal to n minus 2, and then K equal to n minus 1. Right? For each I and J, we check if nums I plus nums J is larger than nums K, right? If that is true, all the numbers between J and K, not including J, can be used to form a triangle with the smaller sides being J and being nums I and nums K, nums J. Otherwise, we need to move K to the left, right? Move K to the left until until K hit meets J. Right. Let's try. So I will move forward. So for int, we also need n equal to nums.size. So int I equal to 0, I smaller than n minus, so n minus 2, right? Minus 1, minus 2, yeah. I plus plus. For each I, for int j will equal to, for each I, j start from n minus 1, j is larger than I, j minus minus, right? And then for that, we have a k. We will move k until j is actually this, and k is equal to n minus 1, right? So let's say if nums k, nums I plus nums j is larger than nums k, right? If it's that, then we say rest of plus equal to from k minus j, right? Then we don't move k, and then we move forward, right? J goes forward, and if it's larger than this, we keep going. If it's not, then k need to go. So it should be while k is larger than j and nums I plus nums j is smaller or equal to nums k. If that happens, k minus minus. Right, so we'll move to the first one. This is larger than, and then we do this, and yeah. And then I'll return num res. All right, let's give this a shot. Oh, I forgot to sort. All right, let's see if it's correct. I'm not sure. Would just run another one. Okay, so that looks good. I do need to also have these edge cases. I think these are good edge cases. Oh, surprising. I think this probably is right. I think it is correct. Pretty decent, huh? This one's pretty decent. Alright, I'm gonna feed my cat. I had first time 2021. This is the first time I do it. Apparently it was pretty bad. Very, very bad. Well, actually not that bad. It's just a binary search, right? That's the binary search one. And then I did another one, this DP to pre-calculate some of the key results. Oh, I'm not sure. And then we had a much better solution in this one. That's exactly what we did for in a while. Yep, for in a while. And two sum, three sum solution. High, low. I think it's the same, O(n) squared. We're able to get in one shot. Yeah, I think that's pretty decent. Binary search, linear scan. Yeah. Okay, that's pretty decent. I think I want to. No, I think we can afford to go one more by doing click this. Yeah, 16 minutes maybe contest. Yes, I think I did this one yesterday, right? Yeah, let's go for the next one. Yes. Split and a merge. That's about right. Alright, but I'm gonna feed the cat. Feed the cat. All right. Back. Split and a merge array transformation. Num1, num2. The following split and merge operation on num1 any number of times. Choose a subarray. Remove that subarray, leaving the prefix empty if L equal to 0. And the suffix empty if R equal to n-1. So remove the subarray, leaving a prefix and a suffix. Reinsert the removed subarray in its original order at any position in the remaining array between any two elements at the very start or at the very end. Return the minimal number of split and merge operation needed to transform nums1 to nums2. Okay, so what we're saying is we have nums2, so it's guaranteed they are the same. Holy crap, the length is only 6, and num2 is a permutation of nums1, so the two are exactly the same. And what we want to do is how many times we cut and then move them around so that they will be the same. Oof, they will be the same. 3, 1, 2. We need to turn this into 1, 2, 3. I mean, technically, because it's a permutation, I can always take the one in the right order, put them in there like bubble sort, right? Yeah, it's just like a sorting. So like we can take this here, so we can take 2, but you can make it better because you notice that this is 1, 2, so you can take 1. I see. So what we need to recognize. Oh, man. Okay, this is too simple. Let's see this one. 1, 1, 2, 3, 4, 5. Turn this into 5, 4, 3, 2, 1, 1. It's completely reverse. I only need 3? What? Remove 1, 1, 2. Remove 1, 1, 2. Put them inside here. Remove 4, 1, 1. Put at the end. Remove 3, 2. Put it. Oh! What in the world? Don't. What is this magic? I don't know. They put 1, 1, 2. So they've actually put 2 behind 3. And then they can put 4 behind 5. What in the world? Oh. Alright, I feel like this might be, maybe it's some knapsack type of problem. It's like, do we move the first one? Do we move the second one? Something like that. Yeah, it's like brute force. But it's also like, you can pick, and there are so many subarrays, right? And after you choose a subarray, there are so many places to put them. I actually have no obvious clue how this can be done. So we can get any subarray, right? And once we get any subarray, the original can merge, and then we just reinsert. So we get any subarray, then we reinsert. And after reinsert, we get any subarray. Nah, that is not going to work. I don't think that's gonna work. I have no idea. I have no idea at all. BFS hash table, what? I don't get it. It is your idea. We'll generate every single possible. Oh my lord. And the first one that hits? And this is your idea, so I don't think it's, yeah, it is your idea. I can't believe it. I just cannot believe it. It's generating every single possibility. Oh, no way. This is no, all right, for one, I don't think I'll use Python to do this. It's much simpler. Yeah, so basically it is, we'll create every single possibilities. Yeah, every single subarray, and I will insert to every single position. And I think the only check is whether this has been seen before. If it's not been seen before, we'll do it. If it has, then we don't do it. Yeah, if you think about that, this is a medium problem, but oh my god. It's just, I've never seen a brute force as this one. And I guess because the length, you kind of, I mean, I was anticipating brute force, but not this level of brute force. It's essentially doing exactly what the problem asks you to do. Right? It's just do it. Ugh. Yeah, I think you don't even have to worry about performance. Dude. I mean, I think I can code this up pretty fast, but dude, this is just, and Python definitely helps. I don't know how C++ can do. You have to have like a hash function to do this. How? You need to hash a string. Yeah, you turn this into a string. That's the only way I can think of it. But hey, we don't have to because there is Python. I don't know when did I do Python before. Here we go. 3690. 3690. Oh shoot! What did I do? Oh, CPP. This is not CPP. This is Py. All right. So this is brute force. Okay, this is probably the most brute force I have ever done. Essentially, we are for each step, right? For each step, we generate all possible subarrays and insert it in all possible positions. And the only savings is that we will keep a visited set to ensure the same array does not get processed twice. Oh, who knows? Very big. All right, so this is what we will do. We'll have a set. We'll call it visited equals to a set, and then we'll have a queue, which will start as, it's going to be a deck of set nums1. Okay, and we'll have target is nums2. I can do set num1. Actually, that's not set num1. I think it's just num1. It's just num1. Yeah, it's not a set. It's not a set. It's just nums1. Okay. While q, right? So current equal to q dot actually q dot pop. Huh? Oh, deck is not defined. My bad. Nope, that's not what we want. Doesn't have. There you go. So this is gonna be a set of tuple. Okay. Oh, I can use tuple actually. But I cannot insert. Yeah, that's fine. So current is just gonna be I'm at pop left, right? So that's current, pop left. And what I do is I will get all possible. Oh. Right? So I have this and this. Da 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 da. Get one out. How do you cut it out? Okay, I can cut it out. Insert at all positions. And this is actually visited dot add tuple minus one. Yeah. So yeah, we find this as the length. Right? A length for L in range. So length has to be 1 all the way to n. Right? Oh, range I think should be n plus 1. This is the length. So we'll have, so for this length, and we'll have this, and for I in range from 0 all the way to n minus L. I believe it's minus L. I'm not quite sure about this. So if length is 1, if length is 1, it's gonna be I plus, so if L is 1, so I is gonna be this. That is not right. So it has to be plus 1. So if I can, yeah, L is 2, so a minus 1, so we can plus, yeah, so that's the range. So we'll have J, right? It's I plus L minus 1. Right? I plus L minus 1. Yeah, so from I to J is the subarray. Then we can say is current and and the sub is current I to J. Remaining is current all the way to I plus current from J plus 1 to the end. Right, so this is the remaining. And then the sub need to insert into every single position in the remaining. So how do I do that? Actually, I forgot. How do I do that? Python insert a list into a list. Append extend plus add a position. I cannot. At given index. Can I do that? I do have insert. What is this syntax? What in the hell? Hold on. Actually, I don't like this. I think it's PT Python. It's PT Python, yeah. So, all right. So this one is 2. How about list 1 from 1 to 1? This is an empty. But if I say this 0, 1 is equal to list 2, then list 1. Oh. Okay, I did not know the syntax. What is? Wait, hold on. Hold on, 。 So if I say list 1, 1, 2, 3. Okay, so 0, 1, 2, 3. Do I get replace? Do I get replacement? Okay, 0, 1, 2, 3. No, 1, 2, 3 should be 1, 2. So actually these 2 gets replaced by 3, 4, 5. Okay, well that's a new syntax. I actually don't know. Yeah, so this is the remain, and then we can put into any position, right? So that means, so we remove the sub, we have the remain, then we shall, Lijk. Oh, I bet you can do list 1. I know. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. So if you do 7, it's gonna insert at this position. Right? Let's say 7 to 7. Yeah. So it has to be, so the 7, 8, 9, 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it had to be 11. There you go. Yep. So this is +1, right? Remaining. Next will be remaining k to k. Ooh, that's actually not right. We'll make a copy. And then next k to k equal to sub. If tuple next is not in visited, then q dot append next, and then visited dot add tuple next. Alright, for each one I added, and then coming back, I got the next I. Yeah. Then we'll finish all this. And we have res equal to 0. So after we go through n is current length, yeah, so if, how do I check if the two are the same? For n1, n2 in zip, nums1, nums2, if n1 equal to and not equal to n2, break, else return res, and return res, return -1, should not hit this part. Yeah, so you check if they're the same. If they're not the same, break out. That means we're not there yet. And then blah blah blah. Once we're done, we are saying res will be plus equal to 1. Like the first step. Right, take it out, move, take it out, move, take it out, move. I don't know. I code this very fast. Oh my goodness, what did you do? If it doesn't work, I'm not gonna do it. At least not today. No way. Alright, so there is something wrong with it. We'll do some other time. There's something wrong with it.